It's Miss Billman, and we're with the 9-7 homework. So on the coordinate grid, points A, B, and C represent ships at sea. So I'm going to zoom in so we can actually see these. This is a pretty tiny plane. I've numbered each of those lines. Now, I use decimals. You could use fractions. But if you see, they they pointed out 1 and 2. So I went through and labeled each one with a 0.25 going up each time. So 0.25, 0.5, 0.75, 1. So A is at 0.75, comma, 1.5. B is at 0.75, 0.25. And this would all be in quadrant 1 because they're all positive. And C is at 2.25, 0.25. And this is one of those things where I just couldn't assume each line was worth 1. I really had to think about how they're all split at. So, explain how subtraction can be used to find the number of unit lengths that ship A is from ship B. Ship at point A, excuse me. So, things I could do. I know each square is worth 0.25. I could go through and count how many squares are between there and then multiply by 0.25. But it's specifically asking for me to use subtraction. So when I'm looking for how far ship A is from ship B, I can subtract the y coordinates. Now I'm subtracting the y because it's vertical. A is above B. So I could say 1.5 minus 0.25. And I would get 1.25. And I should also be getting 5 squares between there if I went through and colored them and multiplied them by 0.25. I would get the same answer. So there's 1, 2, 3, 4, 5. Perfect. Double check my answer. Number 3, explain how subtraction can be used to find the number of unit lengths that ship C is from the ship at point B. So I can do the same thing, except if I subtract the y, we're going to be in world of hurt because that's not going to help. But if I subtract the x, because these ones are further horizontal, that will help. So ship C is at 2.25 and ship B is at 0.75. So I would subtract 2.25 minus 0.75. And I could definitely do the same thing to check my answer of coloring each square, counting them, and then just to double check, multiply it by 0.25. It's always good to have another plan just in case to check your answer. The ship at point B is 300 nautical miles south of the ship at point A and 360 nautical miles west of the ship at point C. So, like I said, there are 5 squares right there. And over there are 6 squares that are between it. So for the 5 squares, that represents 300 miles. So when asked what number of nautical miles does each square, I have to think, okay, I have 300 miles, I could divide that by 5, and that would give me the number of nautical miles per square. I could always double check my answer by dividing 360, that's from B to C, 360 by 6, and I'd still get 60. So each square is 60 nautical miles. Pretty cool when you can figure out things like that. And using this in the real world, of course. And you see, of like, wait, per grid, per square. And I think I just want to settle for square. It just makes more sense. So number 5, suppose a point at 5.5, 6.5 is reflected across the y-axis. Explain how to find the location of the reflected point and then write its location. For questions like 5 and 6, I always draw a coordinate plane and I will label the quadrants. So quadrant 1 is always positive, positive, which is this 5.5 and 6.5. Quadrant 2 is negative, positive, which is actually where we're heading, right? We're reflecting across the y-axis. So 5.5, 5.5, 6.5 ends up becoming negative 5.5, 6.5, because it is still on the positive side of the y, but it is going negative across the horizontal x-axis when it reflects across the y. When you're doing questions like this, I always strongly suggest drawing out a coordinate plane. If you want, you can always label the quadrants. So 1, 2, 3, and 4. 1, positive, positive. 2, negative, positive. 3, negative, negative. 4, positive, negative. Suppose a point at negative 7.75, comma, 7.25 is reflected across the x-axis. So right now I'm in quadrant 2, and it's going across the x, which is negative, negative. So how do I know? Well, when you reflect across the x-axis, the y, so in this case it was 7.25 to begin with, it becomes negative 7.25. I'm still going across in the negative on the horizontal, the x, but when it's reflected across the x, it's flipping over, and now the y is negative. I hope this helps you out with some things on a coordinate plane. Don't be afraid to draw a picture and write it out. Modeling it like that helps me as a learner too. So I hope you enjoy.